Okay, we're going to start day 2 by just a little bit of a review of what we were doing yesterday. So let's just kind of pretend we have a random function here. Just give me almost an exponential type function there. And let's pick out some points. So let's just pick out the point here. I'm actually just going to use x, so the y value there would be f of x, which I know is weird because the function is f of x. And then we're going to pick a second point, and I want that second point to be h units away from this one. So like, let's say you were at 3 and I said I want you to go 4 units away. Well, you'd be at 7 because you do 3 plus 4 to equal 7. So to get this point here, this x value, we're going to take our x value and add h units. So this point, this x value is x plus h, and this y value is f of x plus h, where this one was just x comma f of x. And so let's say I said find the slope. The slope of that line, that secant line that goes through them, the slope would be the y2 minus the y1 over x2 minus x1. So my slope would be at the y2 minus the y1 all over x2 minus x1. Okay, hopefully you can see at the bottom the x's add up to 0. So the slope of this secant line is f of x plus h minus f of x all over h. That is how you would find the slope of that secant line. But we already knew how to find the slope of secant lines. The whole point is we're trying to find the slope of tangent lines. So we're going to have 2 more graphs that we're going to draw, but I want them to be, oh, that is way too big of a graph, but I want them to look almost identical to each other. I want the same exponential here and here. I want the same x value, but I do not want you to put the same second point on there. The whole point is we are trying to turn this secant line into a tangent line. So we want the second point to get closer. Okay, so as I put x plus h here, it's the same point. I'm just moving it closer. What are we actually doing besides moving it closer? What changed about this line? And the part that changed is that h got smaller. The distance between these 2 points got smaller. And so h is getting smaller right now. We're trying to get h as small as we possibly can. However, that's still a secant line, and we would find the slope the exact same way that we found the other slope. And so I'm just going to kind of rewrite it. The slope is still the f of x plus h minus f of x all over h. Because the line is still secant, we find the slope the same way. All right, now what I want you to do on your third picture is I want you to put that second point almost on top of it. I want those 2 points to almost be the same point, but the line is technically still secant, but it looks tangent. So when I draw this little dash there, x plus, I mean, it's so close to being a tangent line. So what did we really do here? We made h as small as we could, and we're going to keep making h smaller and smaller and smaller until h approaches what? We want h, the distance between the 2 points, to approach 0. And then I can find this slope. So the slope now becomes a limit statement. The slope of this tangent line now is going to be the limit as h approaches 0 of that same slope we were finding for the past 2 lines, all over h. And not only is that the slope, but I gave you a random point. I didn't pick the point 2 or a or 5. I was saying, hey, choose any x value you want. So this is how you find the slope at any point. You would just sub the x value in, and that would give you the slope for that at that point. So this is actually a function. This equation is a function itself. It's a function or an equation. That function is called the derivative. This is how we are going to find the slope at no matter what point. They don't even have to tell you any point on there. I want the derivative function, and this would be how we'd find it. Okay, so a big title here, because this is pretty important for us. The derivative function. Let me write it out this time. The derivative function. I'm going to box it, maybe even put a star by it, something. But that's very important to realize is the derivative is a function itself. You can graph it, you can sub stuff into it. It's its own equation. Okay. The limit definition of the derivative function is, and now we're going to start labeling it. So there's notation to mean derivative. We can't use f of x. That was the original. So what we're going to do is we're going to put a little prime symbol up there. Prime in math means change. Well, what kind of change is this one? It's a rate of change, which we've already talked about yesterday. So to find f prime of x, that is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, h is that theoretical distance between the 2 points. Now, 2 side notes. If f prime of x exists, the limit is not dne, if it's a number, then we say f is differentiable. Go ahead and write it down and we'll look at it again. If a function is differentiable, it means you can find its derivative. It's a number. The limit will not be infinity, dne, any of that stuff. That means the function is differentiable. So, this limit is for a function, aka no point. Okay? The other limit, aka the limit as x approaches a of f of x minus f of a all over x minus a, is for the slope at a point, or the number. Okay, it's going to be a number answer. So when we say find f prime, it's going to be an equation. When we say find the slope, it's going to be a number. And so that's when you use each limit. Okay, so let's try a brand new example. I'm going to skip A, and I'm actually going to do B first in the notes. So I'm just going to call this one B. Y equals, or directions might be helpful actually, before we do everything else. Let's go ahead and call this example 3. Directions are find the derivative. Okay, so we're going to do part B first in the notes. So find the derivative of f of x equals negative 7x minus 2. Okay, so I want the derivative function, and remember, the derivative is the slope at any point. Any point along this function, I should be able to find the slope. Okay, now because I did not give you a point, we're going to use the h definition. So let's just go ahead and rewrite it. You're trying to memorize this as you go. Limit as h approaches 0, f of x plus h minus f of x all over h. So let's see what we can replace here. I can replace f of x. I see it. They already told me it, and it sounds silly, but I'm going to write it again. They already told me that f of x was negative 7x minus 2. So how would you find f of x plus h? Notice all we did up here is we replaced x with x plus h. So that's exactly what we're going to do down here. I'm going to replace x with x plus h. So whatever they had for x before, I'm replacing it with x plus h. And now I can distribute. That's negative 7x minus 7h minus 2. But we're going to actually wait to do that. Let's just keep it like this one first. Okay, so now let's go ahead and rewrite our limit statement now with all these things subbed in. Okay, so we have limit, h approaches 0, fraction. We're going to have f of x plus h minus f of x. So f of x plus h, we already wrote off to the side, minus f of x, I'm going to put that in parentheses, all over h. And you need to get out another color and rewrite this above it. This is your f of x plus h minus the f of x. So you can see it. All right, it's a limit. Clean it up. Now, what's your main variable here? Look over here at your limit statement. Your main variable here is h. So you're not subbing in x equals 0. You're going to sub in h equals 0. But let's clean up the top first. Let's distribute the 7. Let's distribute the negative back here. Limit h approaches 0. Negative 7x minus 7h minus 2 plus 7x plus 2. So you're going to have some stuff start to cancel. Well, some of that will add up to 0. Now, not just some of it, but probably the most important parts. Notice that you have negative 7x, positive 7x, negative 2 plus 2. So what's the only term left in the numerator? The one with h in it. Because remember, we need something to cancel. Any term without h should cancel out up top. Draw an arrow, write that, star it. And so now what's going to happen is we have the limit as h approaches 0 of negative 7h over h. The h's cancel. There's nowhere to sub in. H equals 0. So my limit is just negative 7. Well, what does that mean here? That means that the derivative function is negative 7. F prime of x, the derivative function, this is how you label it, equals negative 7. And now I could sub in any number I want. I could sub in any x value, but the derivative is always going to be 7. The slope is always 7. Well, I mean, I hate to break it to you, but you should have known that already. This is a line. You know how to find the slope of that line. Your answer should have been negative 7, or you've made a mistake. So that is the slope at any point. Okay, which we should have already known because that line always has the same slope. Now, lines are the only things that always have the same slope. Parabolas, they're going to have different slopes. Positive slope, 0 slope, negative slope. So let's try a parabola next. Okay, let's try another parabola. Now we're going back over to part A. We've already worked with this function, so we're going to work with it again. I want the derivative. Find the derivative function. All right, so let's try this. We need to rewrite our limit definition. See if you have it memorized. I'm going to use the h one because there's no point. So we have f of x plus h minus f of x all over h. They already gave me f of x. The only thing I need now is my f of x plus h. So let's go over to the side and find it. Everywhere you see an x, replace it with x plus h. So the first x gets replaced with x plus h. Oh, I forgot my 16 out front. Negative 16 x plus h squared. Plus 96 is supposed to be x, so instead I'm going to put x plus h. That's what f of x plus h equals. Now, you can clean it up now, or I might just wait until it's in that fraction par. All right, let's go ahead and start substituting some stuff in. I'll tell you guys, this is going to be a little bit of a long one because we have a lot of distributing to do. So first things first, let's put our f of x plus h in there. Minus f of x, parentheses, negative 16. You're almost always going to have to put a parentheses back there. All over h. Get your other color pen out. F of x plus h minus, I know this sounds silly, but you're going to be so happy you did because these problems, as you can tell, are not going to be easy. All right, we have some distributing to do. I'm going to distribute, let's see, I'm going to go start at the back. I'm going to distribute the negative. I'm going to distribute the 96. I can't distribute the negative 16 until I square out that binomial. So if you know how to square a binomial in your head, go ahead and do that. If not, you write it twice and distribute. So that's going to be x squared plus xh plus xh plus h squared. So x squared plus 2xh plus h squared. And again, some of you might have already learned how to distribute binomials in your, square a binomial in your head. Please feel free. You do not have to write that down over there unless you want to. Okay, so let's go ahead and rewrite this down. I haven't distributed the negative 16 yet. X squared plus 2xh plus h squared. Plus, and now I'm distributing the 96, 96x plus 96h plus 16x squared minus 96x all over h. One more thing to distribute in the top. Okay, let's write it out again. I know it seems crazy. Distributing negative 16x squared minus 32xh minus 16h squared. And then I'm just going to rewrite all that. Oh, I hope I did this right. Well, I'll find out really quickly. And the way I'm going to find out is, remember, anything without h should be canceling out. If it doesn't, you've messed up. Now, don't just start crossing out things that don't have h's. Make sure it adds up here. So I see a negative 16x squared and a positive 16x squared. I see a negative 96x and a positive 96x. This one has an h, this one has an h, and this one has an h. I feel good about that. So let me go ahead and rewrite it. Negative 32xh minus 16h squared plus 96h. Okay, so now I can sub in h equals 0, but we already said everything has an h in it, so I know that the top's going to be 0. So what I'm going to do now is I'm actually going to factor out an h in the top. So let me go ahead and try that. I'm going to factor out my h in the top. Limit h approaches 0. H, negative 32x minus 16h plus 96. And then now you can see, since I factored out the h, these are going to cancel. And I'm going to try my limit again, which means I'm going to sub in h equals 0 everywhere I see an h. Well, there's only one h in there. So negative 32x minus 0 plus 96. Now, there's still an x in it. Well, that's okay. It's a function. Remember, that is the derivative. So f prime of x equals negative 32x plus 96. And now, guess what I can do? Well, I can find the slope at any point that I want. Let's say I want to find the slope at 1. Well, I'm going to just sub in 1 now. And that's actually the first problem we did. If you look at this problem, this was example 1. We found it to be the slope to be 64. If I want f prime of 2, negative 32 times 2 plus 96, that's going to be 32. So really, I have found the slope of that tangent line at every point I can imagine. All they asked me for here was just the derivative. But what that derivative is doing is it can give you the slope at any point that you could ever want. So if I want f prime of 1, 2, 3, and 4, just do this limit definition, and then at the end you can sub in the x values 1, 2, 3, 4. All right, let's try another example, one or two more on this video. I can't decide for sure. So let's just try one that I swear it's on the IU dual credit final every year. They always have, a radical problem. Okay, so let's call this C. Let's call this one g of x this time. Or no, let's just call it y equals radical 3x minus 1. Okay, so I want the derivative function, and I can already tell this is going to be a little tricky. So let's just go ahead and rewrite our limit. I didn't give you a point, so I'm going to rewrite the limit with h in it. Okay. I am going to replace x with x plus h. Now there's only one x in this one, so I'm going to replace that x with x plus h. Now notice I'm not writing it separately out to the side. You can, I'm not going to anymore. So it's still a radical. I'm replacing x with x plus h. That's the f of x plus h. Minus the original all over h. Okay, I would distribute the 3 personally. Three x plus 3h minus 1. And from here, we can sub in h equals 0. It's a limit. Let's try the limit. So if I sub in h equals 0, on the top we get root 3x minus 1, because this will be 0, minus root 3x minus 1 all over 0, and that's 0 over 0. Indeterminate. Do something else. Well, what are we going to do here? Because I really don't want to factor. I can't factor. So I see radicals with a limit. We are going to try to multiply by the conjugate. And that just goes back to some work in chapter 2. So let's go ahead and see if we know what the conjugate is here. For my conjugate, we're going to take the exact same radicals up here, but instead of having this plus sign in the middle, or minus sign, we're going to put a plus sign. All right, let's start by rewriting our limit. Let's not get too messy here. Let's go ahead and rewrite this limit. Radical 3x plus 3h minus 1. Now, we have to multiply by the conjugate, which means I'm going to multiply the numerator and the denominator by the exact same two radicals with a plus sign in the middle now. I'm going to rewrite it twice. So this one's honestly just a lot of writing. Now, these are binomials. I like to put parentheses. Okay, now if you remember from chapter 2, we are not distributing the bottom, we're just distributing the top. The numerator is the reason why we are picking our conjugate, so that's the only one we're going to distribute. And since it's the conjugate, I'm just multiplying the first two and the last two. The bottom is going to stay factored. Okay, I'm going to try to make this font all just a little bit smaller so we can fit more on here. All right, so we have limit h approaches 0. I'm going to distribute the top. I'm going to take the first two radicals minus parentheses. Make sure you remember that parentheses. That's the number one thing people forget, because I have to distribute this whole thing here, that whole 3x minus 1. If you want, you can put parentheses around this one too. It's up to you. Remember, in the denominator, we are not distributing. We're going to leave it like this. Plus radical 3x minus 1 Okay, I'm going to distribute this negative, and I won't write the parentheses on the first one anymore. Limit h approaches 0. Okay, so let's go ahead and get 3x plus 3h minus 1 minus 3x plus 1 all over h. Okay. Hopefully you can see it on the top. Remember, we said anything on the top without an h should cancel. So 3x minus 3x, 1 minus 1. So we get limit h approaches 0, 3h all over h radical 3x plus 3h minus 1 plus radical 3x minus 1. And now hopefully you can see it. The h's are going to cancel. I have a brand new limit. So I'm going to sub in h equals 0 again. And there's really only one spot left that has an h in it. So 3 over radical 3x plus 0 minus, I'll put the plus 0 minus 1 plus radical 3x minus 1. So I have radical 3x minus 1 plus radical 3x minus 1. That's going to be 3 over 2 radical 3x minus 1. Now again, what is that? That's my derivative. So f prime of x, this one they actually called y equals, so I'm going to put y prime equals. It still means the derivative. So y prime equals 3 over 2 radical 3x minus 1. Okay. All right, I know you might want another one to practice. I'm not going to do a whole one, but I will give you an equation. If y equals radical x plus 8, actually I'll really quickly do this. So if we want to, we can call this letter D, but I'm probably not going to spend as much time as I would with you. Limit h approaches 0. F of x plus h minus f of x all over h. So I'll work this out as if I were just working this out. So it's going to be quicker than the last one. All right, limit h approaches 0. Radical, replace x with x plus h minus the original all over h. If I were to envision subbing in h equals 0, it's two radicals subtracted that are the same. So that top's going to be 0, bottom's going to be 0. I'm going to go ahead and multiply by the conjugate. I'm going to change that minus sign in the middle to a plus sign in the middle. Okay, parenthesis, parenthesis. I'm only distributing the top. So x plus h plus 8 minus. When you take the radical times itself, it cancels out. I'm not distributing the bottom. I'm just kind of leaving it as is. Distribute your negative. The worst part is just having to rewrite this denominator every time, but you make sure that you rewrite it every time. All right, we get x minus x, 8 minus 8, and we have an h top to bottom that I will cancel, just not quite yet. Limit h approaches 0. We have h over h, radical x plus h plus 8 plus radical x plus 8. The h cancels. We have a 1 left on the top. Make sure you remember that 1 up there. And so now I'm going to sub in h equals 0 again. So 1 over radical x plus 0 plus 8 plus x plus 8. So 1 over 2 root x plus 8. What is that? That's the derivative. They called my original y equals, so I'm going to call this y prime equals 1 over 2 root x plus 8. And that's your derivative function.